Welcome to this video on using trigonometric ratios and also on labelling the sides of our triangle in order to determine which ratio or ratios can be used. So a trigonometric ratio is a relationship between the sides of a right-angled triangle and its angles. And as I just said, we give labels to the sides to help us decide on which ratio to use. And these ratios are these labels are opposite, adjacent and hypotenuse. And we use the given angle or the unknown angle as a reference point to decide on these labels. So I'm not going to go too much into how we derive these ratios, but here they are. So sine of theta, which is just a little symbol for an unknown angle used in maths, equals our the length of our opposite side divided by the length of our hypotenuse side. Cosine of theta is the length of my adjacent divided by hypotenuse, and tan of theta is my opposite over my adjacent. So I'm just going to go about labeling those sides of my triangle. We know that the hypotenuse is always opposite our right angle, so this value of 72 is my hypotenuse. For the other two, the opposite and the adjacent, I'm going to use this reference angle as a point. So the side length that's opposite theta is this one here, 52.8, and the adjacent can be thought of as the leftover angle, or else you might like to think of it as the angle next to. So the word adjacent means next to. So usually you will only have two of these side length values, which will limit you to which ratio you can use. So if you only had your hypotenuse and your opposite, you would have to use the sine ratio. But in this case, I'm going to write out all of these, substituting in our opposite, our hypotenuse and our adjacent, just to show you. So if I was to write the value of sine theta, I would have my opposite over my hypotenuse. Cosine of theta would be my adjacent, 49 over 72, and tan of theta would be my opposite. Oh, I've done it again. 52.8 divided by adjacent, 49. And if we put these in our calculator and did the operation to get theta by itself, these would all come out as the same value because these ratios work out. Okay, so let's have another look at this one. So I'm going to label my sides. Think about what one would be the hypotenuse. It's always opposite that right angle. My opposite is opposite our reference angle. And then the one left over, or the one next to our reference angle, is the adjacent. So again, if I was to write sine of theta out, I would be using my opposite, which is 14.3 over my hypotenuse, 23. Cosine of our unknown angle would be 18 over 23. And tan of our unknown angle would be 14.3 divided by 18. Now in the next video, we'll look at triangles where we only have two side lengths, or we know our angle and we're trying to find a side length, and this will limit us to which ratio we can use. But for now, I just wanted to make sure that we were okay with labeling the triangle and substituting in our opposite, our adjacent and our hypotenuse.